So thinking about what a point looks like in the complex plane, we can see that we've got a horizontal component and a vertical component. In a sense, it's real and imaginary, but at least in terms of what that looks like, it seems like it should have the same sort of meaning. So we can talk about the absolute value of a complex number, and frankly, I don't know why this section decides to call that thing an absolute value. It's not an absolute value, it's a modulus. It has a special name in this context. They choose to use that one, even though they're going to use modulus again later anyway. But here, that can be thought of as the distance from our point to the origin. That is, the absolute value, or modulus, of z is just the square root of a squared plus b squared. It's the radial distance from the center. So to understand that, we're going to take a look at a couple of quick examples here. For these, we want to find the absolute values, or moduli, of z equals negative 5 minus 12i and z equals negative 3 plus 2i. So, I'll do that. I'm just got to use the formula. In the first case, we're trying to talk about that negative 5 minus 12i. So, we're going to have the square root of a squared, negative 5 squared, plus the square root of square root, all under the square root, b, negative 12 squared. So you square that negative 5 and you'll get 25. Square the 12 and you get 144. Those negatives happen to get caught in there. And we get the square root of 169, where this, hey, what a coincidence, is a perfect square. Where in particular, we always look at the positive square root because we're talking about the radial distance. It has to be a positive value. Here it's 13. In the second case, for that, we are going to be taking the square root of negative 3 squared plus 2 squared, or the square root of 9 plus 4. I should probably cross my z's just to be extra careful, because, you know, it can never hurt when you have bad handwriting. But that will end up being here the square root of 13, which is actually the best we can get. And hopefully seeing these things in terms of two components and a radial distance, vertical and horizontal component, radial distance, that smells like a right triangle. And if something smells like a right triangle, it should, at this point, start to smell like trigonometry. And that's where we're going to get the idea of the polar form of a complex number, which is what we'll see next.